Huge welcome to this series about logistic regression. Grab your coffee and let's start.
Welcome to the presentation. What is this about? In few words, it's a tool, a model that helps us to predict whether something will happen or not based on certain characteristics or features. Depending on our dataset, we are going to predict binary results based on the different values of that dataset. What can we predict? It, for example, for a bank approval, if we are going to be approved or not approved, or even we can predict if a person, if a situation is guilty or if it is innocent. And what about the characteristics, the features? If we are trying to predict cancer, uh, of some person, the responsive variable is going to be cancer or not cancer, based on historical family health, weight, height, heart pressure, and all of those things that can answer our particular problem. So first of all, it's important to know that the logistic regression is a supervised model. You know, we have artificial intelligence models, their respective branches. In this case, from the machine learning branch, we have the supervised or non-supervised models. Logistic regression is a supervised model. We are obtaining our answer in a probability key. Our answer is going to be between a range of 0 to 1. And when we are trying to determine if it is whether yes or not, or in our example, approve or not approval, we are commonly putting at the threshold in 0.5. We can also understand the logistic regression and the linear regression with an important point of analysis. Both techniques build model from a linear combination of the features. So the logistic regression is going to use the sigmoid function to transform the linear combination, which is going to give us the probability to determine if it is 0 or 1. So how does it handle the different features? In this chart, we are comparing variable 1 versus variable 2. And as you can see, we can split, we can divide into perfect groups when it is going to be 0 or 1 or the different binary results. But in this case, we are only using two variables. As we are putting more features, more variables of our dataset, it is going to be a more complex function. So the important thing is to understand that we can handle a lot of variables, but it's not going to be a simple analytical solution. So that is the reason of why we use Python or R or all of these programming languages to solve the different problems. To close this simple explanation of the logistic regression, I want you to think in these three important points. We have several factors in which we have to think when we are using the logistic regression. But here are three important ones that you will see in any case when you are using this model. First of all, we are assuming a linear relationship between the predictive variables and the logarithm of the probabilistic ratio that are called the odds. And this is not commonly in the real world. When we are using plain datasets or simple datasets, this can be possible. In the real world, it's not always going to be like this. The second point is that we are limited to only two possible results, yes or no, 1 or 0. There are other models that allow us to have more categories. Low, medium, high. Approved, approved with issues, and not approved. You know, in other models, we can have different categories. In this logistic regression, we only have two. Is this necessarily a bad thing of the logistic regression? Not, because sometimes we only need two possible options. Approved, not approved. Healthy, not healthy. So it depends on your objective. And finally, we are also assuming that the predictor variables can perfectly separate the classes. And this is not always happening. Let me return to the chart. Sometimes we will have answers that must be near to 1 that in the real world are more near to the 0. So this is going to affect the performance metrics, but sometimes this model is going to be the best model to describe our reality. Remember that in machine learning, we are never going to find a model that solves in a 100% or system. If we have that result, it is an overfitting problem, and we will have to fix that. So now with a little knowledge of this model, we can start understanding the mathematical aspects, and then we are going to program in different languages how to build the logistic regressions. See you in those classes.